Hello everyone, I'm Karthik Reddy, your Canadian CS 1057. Today I'm gonna discuss about CPU scheduling algorithms in Operating Systems Lab Exercise 4. The aim is to write the program to implement CPU scheduling algorithm for for first come first serve SJF priority and round robin scheduling using C++ or Python. Description. What is process scheduling? The process scheduling is the activity of the process manager that handles the removal of the running process from the CPU and the selection of another process on the basis of a particular strategy. Process scheduling is an essential part of multi-programming operating systems. Such operating systems allow more than one process to be loaded into the executable memory at a time, and the loaded process shares the CPU using time multiplexing. Types of process scheduling. The first type is FCFS scheduling algorithm. FCFS means first come first serve. It is the simplest algorithm in process scheduling. In this algorithm, the set of ready processes is managed as FIFO, first in first out queue. The processes are serviced by the CPU until completion in order of their entering in the FIFO queue. A process once allocated, the CPU keeps it until releasing the CPU, either by terminating or requesting input or output. For example, interrupted process is allowed to continue running after interrupt handling is done with. This is the algorithm for FCFS. The question: implement the CPU scheduling algorithm using C++ or Python. This is the code for the C++ program for FCFS, and we get output as here. This is the output. The second process is SJFS scheduling algorithm. The shortest job first scheduling algorithm chooses the process that has the smallest CPU burst. This is the algorithm. Sort all the process according to the arrival time, then select that process which has maximum arrival time and minimum burst time. After completion of process, make a pool of process which after till the completion of previous process, and select that process among the pool which is having minimum burst time. This is the C++ code for SJF. SJF means shortest job first algorithm. We can see here, this is the output for SJF. Enter the number of process. I gave 4: process 1, 2, 3, 4. The process ID, arrival time and burst time. And the next process is priority scheduling. Priority scheduling is one of the most common scheduling algorithms in batch systems. Each process is assigned a priority. Process with the highest priority is to be executed first. Algorithm. First input the processes with their arrival time, burst time and priority. First process will schedule which have the lowest arrival time. If two or more processes will have lowest arrival time, then whoever has higher priority will schedule first. Now further processes will be scheduled according to the arrival time and priority of the process. Means here we are assuming that lower the priority number having higher priority. If two processes priority are same, then sort according to process number. The final one, once all the processes have been arrived, we can schedule them based on their priority. This is the code for C++ code for priority scheduling. This is the output, and you can see here I have entered the process numbers 3. Burst time, first one burst time 25, priority 1. Burst time 24, priority 2. Burst time 23 and priority 3. And the average waiting time is 24 and the average turnaround time is 48. The final one, round robin scheduling. The scheduling algorithm is designed especially for time sharing systems. It is similar to FCFS, first come first serve scheduling, but preemption is added to switch between processes. The algorithm for round robin scheduling: create an array to keep tracking of remaining burst time of process. This array is initially a copy of BT burst times array. Create another array to store waiting times of process. Initialize this array as 0, and we have to initialize time as 0. Keep traversing the all process while all processes are not done. While all process are not done, do following for ith process if it is not done yet. If REM burst time I is greater than quantum, T equal to T plus quantum. Burst time REM I equal to quantum, else T equal to T plus burst time REM of I, waiting time of I equal to T minus burst time of I. Burst time REM of I equal to 0. This is the C++ code for round robin algorithm. And this is the output for round robin algorithm. I have entered total number of process 3. Enter the arrival time, burst time for all the process. Arrival time and burst time for process 1 are 4 and 3. Arrival time and burst time process for process 2 are 3 and 2. And the arrival time and burst time of process 3 is 2 and 1. Enter the value of time quantum 2. And this is the turnaround time and waiting time. Average waiting time is minus 0.3333. Average turnaround time is 1.66667. The CPU scheduling algorithms and estimated the turnaround time and waiting time for the given problem. FCFS, SJF, round robin priority have been executed and the output has been verified. Thank you.